also times NO2. Is that correct? Did I do anything wrong? Okay. So obviously you can factor out the NO2 if you wanted to. But coming back over here, now we wanted to substitute that in to this NO3 term, right? So you get K2 times NO2, and now what is NO3? This whole thing. So K1 N2O5 divided by, I'll factor it out now, NO2 times the sum of these two rate constants, and that is equal to K3NO. So does this simplify on the left? Yep. That's it though. And now I can solve for NO. So I'll do that over here so that both of our intermediates are right next to each other on the board. Yeah, the N2O5s also cancel because they're on both sides of the equation. So NO is just what's on the left divided by K3. So you get K2 times K1 over K3 . Yeah, minus 1. And now I can substitute both of those into the original equation that we wrote down. So I get K1, concentration of N2O5, minus K-1, concentration of NO2, and then the concentration of NO3, which is that species. I'm not going to have room. Wait. NO, which is just that grouping of rate constants. Any questions? Did I make any mistakes? Or forget to simplify anything that could have been simplified? Obviously the N2O5 cancels out, or doesn't, excuse me, can be factored out. Otherwise, I think this is fairly simplified. I got rid of the obvious things. Everybody knows how to do that, right? I had to know how to write out elementary rate laws. I had to be careful with things like stoichiometry, even though this problem, by Jason's good graces, since he wrote the test, didn't have a lot of tricky stoichiometry in it. And I had to know how to do algebra. Of course, that's not all. That was part A. I didn't tell you which species you could apply PSSA to, but I did tell you, for instance, some of the species were radicals, you guys feel like you would know what to do?
Radicals.
Right? Radicals are almost always going to be things where we're going to apply PSSA. What do we never apply PSSA to?
Products or reactants.
Products or reactants, yes. So if you're a bit lost, if I don't just be nice and say you can neglect, that these two concentrations will be low, then look at the mechanism, look at what are my intermediates, in other words, what's produced and then consumed later, and are any of those intermediates things like radicals or ionic species, which are often short-lived. Not always, but often. Okay. Part B. Says, is it possible to define an effective rate constant for this reaction in terms of the elementary rate constants? And if so, what is K effective? So, what is K effective? Not for this problem, but in general. What does it mean to have an effective rate constant?
Well, it's like a number and then the case.
A number and then the case. There can be a number there.
You can group all the K's up.
Yeah, I think that's a good way of putting it. You can isolate all of the rate constants into one lumped parameter. So let's see if we can do that here. What do we notice about this reaction? Yeah, obviously I wouldn't be asking the question if we couldn't, right? But what do we notice about this reaction? What concentrations are in the reaction? Just N2O5. And what's more important than that is N2O5 is in all the terms, right? So let's simplify this one more level. We didn't simplify it all the way last time. It's almost as if I knew what was coming. Sometimes I prep. And we get, we'll put it over here, N2O5, and then what goes inside? K1, right? Plus this, sorry, you're right, minus, but this whole thing, everything that's not crossed out over here and not N2O5. So minus, I can't read that, K minus 1 times K1 divided by K minus 1 plus K2. Is that correct? Yeah, it looks like a product of the two K1s and then the last term, God, I left myself space and everything. Which is also, no, this one's plus. K2, right? K1 over K1, this same thing. K minus 1 plus K2. And we can even simplify this a little bit more, right? Everybody see that? K1 appears in all three terms. So I can factor that out. These two terms have the same denominator. So I can couple those. You get 1 minus K negative 1 plus K1. Except this is minus and that's plus. That's got to be a minus as well. Yeah, and that's a 2. I think somebody said it. Even if I made a mistake there, at this point, it's algebra, right? What is K effective?
Everything times N2O5.
Yes, everything except N2O5. So this whole thing, 1 minus K minus 1 minus K2 over the sum of those two rate constants times K1.
How would you do E effective? I know how to do it when they're like multiplied, but when they're adding and subtracting, what does that turn into?
That's a good question. So we're going to talk about that in just a second, part C. But that's a good point. Yeah.
On like an exam, so like part A, like if someone stopped there, that would be fine. Like you wouldn't have to go.
You don't have to simplify it now, if that's what you're asking.
At all.
Don't be a jerk about it. Like, if you got A over A, yeah, you can cross it out and make the grader's life meaningful. But no, I'm not requiring you to find every single little simplification in there. But obvious ones, and remember, it might throw you off too. You might report something second order later because you didn't cancel out the fact that it was in the numerator and the denominator. Yeah, in the back.
For that one, for what you got for your K effective, why didn't you like simplify it further down to just be with K terms only?
You're talking about this?